When I think about astronauts, I usually picture one person floating around in space by themselves. But getting a person into orbit actually takes the cooperation of hundreds, even thousands of people. From the engineers who built the rockets, to the instructors who train the astronauts, to the people at mission control who coordinate the entire mission. And let's not forget about all of the expertise and politics that go into developing space policy. Hi, I'm Madeline from WowSTEM, and today I'm talking with someone who has done some amazing things in all the behind-the-scenes work that goes into manned space missions. Her name is Madi Sengupta, and she's an expert in space policy and strategy. She's worked at NASA, the American Institute of Aeronautics and Astronautics, and even at the White House. Thank you so much for taking time to talk with us today.
No problem. Happy to be here.
I want to start by talking about some work you used to do at NASA. You used to be part of the teams that train astronauts for their missions, is that right?
Mm-hmm.
What kind of training do astronauts need before they go through missions?
So astronauts need to understand how the space station works, and when I was there, also how the space shuttle works. And so the training is basically encompasses every system that's on the space station. So everything from how the power system works to how life support works. My particular area of expertise is robotics. And so I trained the astronauts how to use the robotic arm on the space station.
A robotic arm, what kind of things is that used for?
So at the time, it was used significantly for assembly, putting together the space station. So we were bringing up parts, modules with the space shuttle. And so the robotic arm on the space station would grab the module from the payload bay of the space shuttle and move it around to attach to a part of the space station. These days, it's used for since we don't have the space shuttle anymore, and we're now the space station is complete in its assembly. We use it for spacewalks. We use it for just surveying the space station to make sure things are okay. And then recently, I think there was assembly or a reconfiguration of some of the solar arrays. So things like that, just kind of maintenance for the space station.
I think it's amazing what astronauts have been able to accomplish in space, considering all of the difficult circumstances of just moving and operating in space. That's
Absolutely.
Really neat. Wow. So you've also spent some time in mission control at NASA. And in the movies, there are people that are like sitting around computers in one big room. Is that how it actually is?
Yeah. So the mission control is, what you see on TV and in movies and stuff is the front room, what we call the FICR, the front control room. Those are the folks who are monitoring all of the systems on the spacecraft to make sure it's going okay. You've also got the flight director who's kind of making sure the whole mission is going okay. And then you've got the capsule communicator, the CAPCOM, who's speaking with the astronauts on board. And then you've also got what they call mission engineering rooms. But those are the engineers who very likely are either they were designing or built the hardware, or they're experts in how the hardware and the software operate. So if the flight controllers run into any significant issues or the astronauts run into any significant issues, the MER engineers are there to make sure that everything, that they can kind of troubleshoot and then send information up.
Okay, so all those people in the room, they really are doing more things than just saying we have liftoff.
Exactly.
A wide variety of jobs and monitoring systems.
Exactly.
Okay. How do we talk to astronauts in space? Is it like radio, or are you texting?
So they can get emails. So that, there are uplinks of data. So basically uploading information up to the space station so they can get emails through that. But typically there's a capsule communicator, CAPCOM console in mission control front room. And those folks are in constant communication with the astronauts. So if there's issues that arise or there's instructions that need to be given from the ground up, they will be the ones to communicate. Or if the astronauts need to communicate down, they communicate down through the CAPCOM.
Is that going to work the same if we have astronauts on, say, a mission to Mars or the moon when they're a lot further away?
It'll be a little bit different. Right now, communication is almost real time. It's very, very close to, you say something, they hear it, they say something back, and you hear it, and there's not too much of a lag. On the moon and definitely for Mars, there will be more of a lag. So I think what we'll likely see is communications protocols in place where maybe you're not doing things in real time, but you're building for the extra time that it will take to send and receive information. So it could be something, as simple as you only get voice and data information twice a day, right? I'm making that up. It's not, I don't know if that's exactly what they're looking at, but it could be something like that, where in the morning and in the evening, what you need. The challenge with that is that if issues arise, you're not going to be able to troubleshoot them like you can on the space station right now. So the astronauts who will be going to the moon and Mars will need to be, familiar with the systems that they'll be working with at a probably a little deeper level than they do now.
So shifting a little bit, you were also a member of the White House's National Space Council. Could you tell us what the Space Council is?
The Space Council is an office that sits within the Vice President's office at the White House, and it's in charge of just making sure that space activities across the U.S. government executive branch are coordinated. We want to make sure that we're not duplicating efforts, or one agency or department isn't doing something that is different than what another one is doing, and we're not kind of getting to the same results. The other thing we do is just make sure when the Vice President engages on space topics. So, for example, last year she went to the first attempt of the Artemis launch. The Space Council is preparing her to make sure that she understands kind of what she's seeing and where she's going and who she's interacting with and why it's important. So those are kind of the two big things that the Space Council does.
And what kind of things are important to consider when we think about space policy?
Learning how the government works, I think, is one of the main things, and just understanding of what all the different agencies that work on space do. So I was the Civil Space Policy Director, and so in that portfolio, I oversaw kind of the policies and programs in place over human spaceflight, over Earth science and climate. And so it was really understanding what all NASA has going on in human spaceflight. What does NASA do in Earth science and climate? What does NOAA do in Earth science and climate? Same thing with USGS. There's so many, we think of space and we think of human spaceflight. We obviously think of NASA, but then there are other departments and agencies within the government that do different things that are related to space as well. And so it's really one of the main things is like really understanding what is happening across the government.
That's really interesting. I always think about the science when I think about space travel, but I don't usually think about all the politics and policy. And clearly that matters a lot, especially when we're sending humans up there.
Definitely. And, the money that pays for all of these programs comes from the U.S. government. And so in that respect, it's really important because we have to be able to explain, well what we're doing and why it's important. And the same thing is true for as we kind of build partnerships internationally, making sure that we're able to explain why those partnerships are important, why those people should be involved in space. And so there's this other aspect that's not technical to space altogether that pretty much, I'd say, kind of goes hand in hand with all of the science and the technology as well.
So I'm curious to hear more about how you got to where you are today. Could you start by telling us where you grew up?
Sure. I grew up kind of all over the place. My dad worked in oil and gas, so we moved around a little bit. I was born in India, but we moved to the States when I was about 4 or 5, and spent many years in Louisiana. We moved to Texas right before I started high school. And I was fortunate that we moved to the Houston area because that exposed me to some of the student programs that NASA does. And so I knew from when I was little growing up that I wanted to work in space. And I think the move and being closer to Johnson Space Center kind of helped with getting more actual experience there. And so I was able to I did a few student programs through high school that kind of exposed me to the different job opportunities at NASA and helped me kind of decide what I wanted to pursue in undergrad. in college. And then I was able to do basically an extended internship at NASA while I was in college, which led to my job thereafter after graduating.
So even before you moved to Texas and you were near a lot of the space centers, even before then you knew that you wanted to be in the space industry.
Yep. Yeah. So I remember when I was probably 7 or 8, looking through books that had pictures from the Hubble Space Telescope, and that was kind of the initial hook. And then one summer we actually we lived in Louisiana, so we drove to Houston and visited Johnson Space Center. And I remember walking through Mission Control during one of the tours there, and just feeling like that was kind of what I wanted to do, and that was it.
I've been to the Johnson Space Center as well, and like walking through Mission Control felt so emotional to imagine all of the accomplishments that were facilitated from that room. What did you study in college? And you mentioned that led to a great internship.
And so I studied electrical engineering. We had a couple of areas of focus within that, but I knew coming through my experiences at Johnson in those internships, I knew that I wanted to do more mission operations, training, flight control kind of work. So that was, while my engineering education was super important because I think it helped set me up for just understanding how to problem solve and address challenges in a more kind of systemic way. So, the experiences that I got through my internship were kind of the catalyst for helping me decide where I wanted to go after graduation.
It sounds like at least for me, in my STEM journey, I've had a lot of challenges, times that were difficult to overcome, or times I almost thought that I would quit. Were there any times in particular where you faced things that were really hard to get through, and how did you overcome it?
Yes, absolutely. So the best example I can think of right off the bat is physics was never my strong suit. Electricity and magnetism, like understanding electromagnetics, was not was not intuitive to me. And so in college, in my degree, because it was electrical engineering, I had to take 2 of those classes over my semesters. And both of them I did not do well on learning. And I definitely remember one semester, and I think it was one of those classes, where I started looking at other majors, trying to see what made most sense based on the credits I already had. And thankfully I didn't. And I think what helped tremendously was having those internships, because it wasn't 4 back-to-back years of school that were so interesting, but maybe not super intuitive all the time. I could break it up and kind of see the real world applications of some of the things that we were learning in the classroom.
So even though it was really hard, would you say that it was worth it to push through?
Absolutely. Definitely.
That's really inspiring that even though it was a very difficult thing for you to get through, you've still gone on to have an amazing career and meet all sorts of awesome people and have, it sounds like, a really fulfilling experience in the space industry. Well, it's been hugely inspiring to talk to you today. You're a great role model for young scientists, and I've really enjoyed learning from you and hearing about your story. I'm wondering if you have any advice for young people who are thinking about a similar path maybe to yours.
A 2-part kind of advice. One is do all the things that can help you figure out exactly what you want to do, because the more clear you are over time of what you want to do, and I won't say it's easier to get there, but at least you know what you're heading towards and you can make decisions based on that. And then 2, just explore all the non-traditional routes into STEM. There's lots of them. And I think the more you speak with people, the more you'll become exposed to those. I had only learned about the co-op program because of my one of the student programs that I did at Johnson. And so the more exposure you get to those types of different routes that people have taken, I think the better equipped you are to figure out which one's the right one for you.
A message that has become clear is that there's so much room in space for people who are interested in everything and anything. We need artists and politicians and social scientists. You know, we need everyone in order to really succeed in space travel.
Absolutely.
Thanks so much for taking time to talk with us today. I'm really excited to see what's on the horizon for humans in space. And it seems like there's a lot of space policy left to figure out in the coming years, particularly as the space industry expands and we get closer to realizing our craziest sci-fi dreams.
Absolutely.